Thank you very much. Paris-Louis, good morning. My presentation will be more contemplative than the presentation of Ike, but it doesn't matter. Thank you, Ike, for your presentation. You allow me to not define again artificial intelligence, deep learning, RNN, LSTM, and so on. I'm very impressed by the computing power you can provide. So during my presentation, I would like you to keep in mind that AI technologies and cultural heritage, there is something wrong, something bizarre in the title. In fact, as Ike said, for deep learning technologies, we need a huge amount of data for having good results. And when you are working on cultural heritage, it's very difficult to have a huge amount of data. But before starting anything, thank you very much for the organizers of this major event. I'm very honored to be here today, especially in this place. So my presentation will continue a bit the discussion started yesterday during the panel Connecting with Culture. And the first question of my presentation is very simple. What are or what will be the benefits of AI for cultural heritage, and especially for Armenian heritage and Armenian language, because the language is a heritage. And more precisely, how development in artificial intelligence, and especially in deep learning and heritage studies, can affect each other. It's not a so simple question. So I will speak as the CEO of Calfa. Calfa is a startup, a French startup that is specialized in natural language processing and text recognition for very poor endowed languages, so languages with very few resources, as Armenian language, Eastern Armenian, but especially Western Armenian and Classical Armenian. So that means for Calfa, creation of open databases, lexical databases for natural language processing, databases of handwritten characters, of lines of handwritten documents for training some system of text recognition, and database of text in order to make some text analysis. That means also handwritten text recognition. So we are operating as a service provider for companies or individuals that are dealing every day with a huge amount of paper documents and want to extract information from this paper document with value. And we are also working for customized IT project for libraries especially. So for instance, a library that needs to digitize its collections and to promote the results. So we are acting for digitization, extraction of the information, and valorization with creation of database, search engine, and so on. Of course, the list is not exhaustive. So, at the beginning, we have found Calfa to facilitate the accessibility to Armenian culture. From a diasporic point of view, people with Armenian roots don't know much about Armenian literary, Armenian history, and so on. They hardly know how to speak. I'm a good example of that. So one of the solutions we have found is to facilitate the understanding of historical witnesses. From a picture of a printed document, from a handwritten archive, we extract the text, we analyze the sentences, and provide useful data as translation for classical Armenian text or text analysis for understanding the meaning of the document. For that, we are using deep learning technologies, and we can already have some free benefits of that. You can extract information with value of these documents, any kind of documents, paper, handwritten, printed documents. You can increase the accessibility to the content, and you can promote it and allow people to discover this heritage. And the first point to which I would like to draw your attention is a project as Calfa, like completely designed for heritage, can now have some concrete applications in the daily life at different levels. And we will see it together in a few minutes. But before we go any further, let me show you the Kalfa oscillator in motion, because a demo will be more clear for everybody than any speech, especially with my French accent. So let me just go to the software. It's not exactly a software. So I have chosen some pictures provided by our partners. Up, I will be bigger. Yes, look. Where am I? Okay, not in the good place. Just let me. Yep. Where is my mouse? Somewhere. You see it? Where I see it? Okay. Okay. So I have chosen some pictures of our partners, so especially documents from the Matina Daran and the Bulac Library of Paris. So it's a handwritten document. You will see it's very difficult to read, especially for someone like me. So I have some pictures here. I open everything now. So it's a command line, but up, it works well. Where is my mouse again? Here. Up. So we have some bibliographic records like this. We have a manuscript from the Bulac Library like this. It's written by the French professor du Laurier in the 20th century. I have another bibliographical record. Sorry, some difficulties to... A manuscript in Nodorkir provided by the Matina Daran, and another bibliographical record here. So, as you can see, it's very, very difficult to read it. It's very similar to modern handwriting. And if you have to process, to extract the information manually, it will take a lot of time, and so it's very time consuming, so money consuming. So, I will not speak aloud. We can go for the recognition. Record. Up. I will take, I don't know, this one. MEI. It's the third one. Tac. We want a TXT file. Yep. So maybe we have time to grab a coffee. I don't have a good GPU of my computer. Oh, it's okay. So I have now a TXT file. So let me sometimes to open it. TXT. And it is here. So it's not this one. It's this one, not this one. You see it? Yes, thank you. So, up. I don't know if there is some people that are able to read it in the room, but I think the results are not so bad, in fact. Of course, if you are looking closely to the result, maybe I can put it bigger. If you look closely, you will find some mistakes, of course. So I suggest to not look closely. We can try with another picture. For instance, the Nodorkir manuscripts provided by Matina Daran. It's MM, I think, yeah. Yeah, MM, okay. We want a TXT file. So when I see such kind of document, I'm always thinking to a doctor, because in France, when a doctor gives you a prescription, it's always unreadable. So I think it's okay. No, it's still processing, and it's okay now. So we can read it. Yeah. So Nodorkir, where are you? Yes, you are here. Yet, and you book. And Yep. Yep. So as I said, it's a contemplative presentation. So I'll let you try to find the mistake or to read it. But we are around, in fact, for this kind of writings, around 95% of good recognition. So it's not 100% of good recognition, of course, but we can already read it with 95%, hopefully, and we can develop some search engine with this kind of results. If you want, we can try on this one. It's very difficult, or this one, it's already done. This one, well, too easy. No, this one. MEI, faux. Faux. TXT. I'm ready to open it. I promise it's the last picture. MEI. TXT. So, okay. I'll let you 3 seconds. I have nothing interesting to say about that. The results are very clear. Okay, good. So we can go back to the presentation. So if we are now able to reach results like this, so I said around 95% of good recognition for this kind of writings, we are around, for all manuscripts, around 98% for Yelgatakir script, Bolokir script, and so on. It's thanks to our partners who provide us some pictures of manuscripts and handwritten documents. So especially the Institut de Recherche et d'Histoire des Textes from the CNRS, the Nubar Library of HGBU, the Bulac Library, and especially the Matena Daran, with which we are in a partnership since March and performing recognition of Noderkir text. So actually, we are currently recognizing 50,000 archives in Armenian, especially archives, letters from the 20th century about Armenian genocide. And we are working with 7 partners, 7 manuscript centers around the world. So it's not the same slide than the previous one, but I didn't have any idea for the pictures. So I agree with Racha, who yesterday explained the necessity of building digital libraries. And of course, there is actually in the world a big, very big dynamic of digitization of resources. For instance, there is a time machine project in European Union, which aims to digitize all the medieval manuscripts of Europe and to provide to people a map of the cultural heritage, of the European heritage. And, but there is no necessity to go so far. In Armenia, there is a lot of initiatives. For instance, digitization of the National Library of Armenia, of the Fundamental Scientific Library, and of course, the Matena Daran, who is involved in digitization since a lot of years. But when you have a picture of a manuscript, a picture of an archive, what is the next step? You can do anything with that. So the key for the future is to access to the data located in these pictures. And for that, we need deep learning, we need artificial intelligence, not because a human couldn't do that, but because the volume of documents is beyond belief, of course. So I don't remember when, but in 2019, I have made an index of complete and digitized and online manuscripts, Armenian manuscripts, old manuscripts. And you can see that around almost half of the manuscripts have been digitized in the world, but only 3% are available. We count almost 31,000 Armenian manuscripts, all manuscripts. So you can imagine that if you digitize everything, you have almost, at least 15 millions of pictures. So it's very, very complicated to process it manually very quickly, of course. So you can see that digitization process is in a good phase. So there is a need, and I don't speak about archives and modern documents, of course. For instance, in the Bulac library, in the Nubar library in Paris, it's a very small library, roughly speaking. You have almost 800,000 archives for a very small library. So I let you imagine how many archives you can process. So my third bullet is a bit mysterious. It's not a remake of knowing the past to understand the present and build the future, not yet. In fact, the fact is that written heritage is more and more inaccessible and reserved for specialists. And it is a paradox because there is a huge dynamic of digitizations. This heritage is a keystone of our civilization. My last example on manuscripts gave you some obvious examples of applications. With recognition, with text recognition and natural language processing, you increase accessibility for the public, you speed up the works of editors and philologists, you spare time in looking information in all of it, you ensure the preservation of natural heritage content, you simplify access and understanding, and so on. You can also imagine a lot of different ways of applications, like augmented reality for museum to improve the experience of visitors, and so on. In fact, if you can imagine it, you can do it. But there is one thing we have missed. For succeeding in the recognition of modern handwriting, so I show you again this kind of writings. So for succeeding in that, CALFA have almost only trained the system, the artificial intelligence, with old documents. So that means with very old documents, we are able to recognize modern documents. And it opens new perspectives for Armenian language. Come back to this one. Yes, practical application of this kind of artificial intelligence is in the daily life are infinite, in fact, because it allows you to spare time and money. So don't put words in my mouth. I don't want to change people in lazy people or to steal their jobs. It's absolutely not the idea. So we can use this kind of technologies in different ways. So for instance, a post office that needs to sort automatically the letters by reading the address on the envelope. We could also extract information of invoices. We can also create e-books from paper books very easily. And if you are a lazy guy, you could want to authorize business cards and instantly have the LinkedIn information of your contact on your smartphone. But more concretely, administrative forms can be automatically processed, especially if you are talking about e-government. You can avoid frauds or prevent frauds. You can identify a copyist in a picture and so on. So there is still a lot of big quantity of documents that have natively written and not digitized. So there is something to do. And to bring very slowly my speech to a conclusion, I would say that we are at an interesting crossroads where AI meets all sciences, like paleography and so on, linguistic, and could benefit to people. In CALFA, we truly believe in that. Of course, I have focused my speech on written document, but it is exactly the same thing for different kinds of heritage. So one of the best examples is with buildings. Photogrammetry and machine learning can allow us to create very, very precise 3D models for preservation, for tourism, for archaeological needs, and so on. You can have a good example of that in the Facebook page of CALFA, but the third bullet here and the third bullet here and here, in fact, it is not pictures of Garnier or Gerhardt and so on. It's 3D models made by the French startup Econem. So we have done a very good job. It's an example for heritage, for preservation of the heritage. But now you can imagine the same technology in order, if you have, for instance, an earthquake, and the building is destroyed, and you can identify the stone in order to rebuild the building. Or if you want to train your system with pictures of towns or pictures of buildings, you can predict some good installations, good construction. I will succeed. Good constructions for of new buildings in your town. So I spare you the practical application of machine translation. Automatic translation is very obvious, especially for you. Finally, this kind of interactions between heritage, artificial intelligence, business is very, very close to the time machine project. We intend to allow to the general public to explore their own past by innovations, big data, and open access. Something like this for Armenian could be very interesting. And next week, we will have precisely a conference in Paris, Digital Armenian, who aims to see the way of collaboration, the way of data exchange, open data, interoperability of the data for Armenian language, for initiate a discussion of this kind, of how to build this kind of technologies for Armenian language, and how to spare innovations. Thank you for your attention.
Thank you, Sean, for a very interesting talk. So, are there any questions?
I have actually a few questions. But let's start with a couple. So, first of all, do you have some sort of evaluation of the correctness of your reading results? And do you plan to use, or do you use the understanding of the language to improve that result? Because you can do it two ways, right? Mm-hmm. You can train your intelligence or your algorithm better to recognize the character, or you could recognize the word, even approximate the word, even with the OCR recognition errors. Yeah. So, two questions: do you have any indication of the sort of effectiveness or correctness of the recognition, and do you use the language engines or artificial intelligence in that to improve that?
Okay, thank you for the question. So indeed, for evaluating our results, we are using the CIR metric, so character error rate. So we have a ground truth, we have the prediction, and we are comparing with it's a Levenstein distance for having some statistics about good recognition. So for all the scripts like Yergatakir, Borokir, Nodorkir, we are around 95-96% of good recognition. It's only a raw results. There is no post-processing with a language model and so on. So of course we can improve it with a post-processing. It's the next step. But actually, because we are working on old heritage, old manuscripts, something we can define as a mistake is not a mistake, because the mistake is in the paper, and for editors and scientists, we need to keep the mistake. So it's not an easy solution to do a post-processing like that. But yes, it's the next step. Yeah.
Any other questions?
I wonder what is the most complex or valuable part of your products? Data. It's a model that you develop, because there are some open source solutions like Tracirc that you can learn to put some data. What is the most valuable part of your product?
Difficult to answer. I didn't expect this question. I think I think our innovation is to be able to have very good results with a very, very, very small database. So we are able to generalize what is an Armenian letter with a very small database. For instance, for being able to recognize this kind of script, and all of our script, Yegetekir, Pororkir, and modern handwritings, we have only 150,000 characters in our database. So that means if you consider all the scripts and all the letters, less than 3,000 different shapes of IPE, maybe only 100 different shapes of C, and so on. So I think our innovation is here. And of course, we have good results.
Any other question? Yes, there is a question.
Recognition of handwritten in general characters and handwritten is very difficult, and especially in text. Okay, so my question is, what methodology did you use? What is the correctness of this methodology, and how did you prove that really your system can really bring handwritten text into the printed form?
I'm not sure to understand the question.
The methodology you're using, what is the correctness of this methodology, and how did you really assure that this methodology is working?
How many times do you ask to answer to this question? What is our methodology? I will try to answer. In fact, we are collaborating with different kinds of institutions around the world, especially the Matenadaran, for all manuscripts.
In a technical part,
Yeah.
Matenadaran, but just to use many times artificial intelligence. But
What methodology do you use?
It's not okay. Yes, I'm going to this point in a few moments. So we have very, very different kinds of writings. We have very different kinds of handwritten documents with very few data for each. So actually, we are using some LSTM and RNN models. It depends on the kinds of writings. Because, as Ike said, it's very, very efficient now. We have tried with different kind of neural networks, some CNN, some RNN, some LSTM. We have checked the latest updates in the state of the art, faster SNN, and so on. And so we have made some comparisons with the CER metric, so the character error rate, in order to see what is the best solution, what is the best combination, and how we can improve these technologies.
Do you have a follow-up question? Is there any other question? I've got a final one, if I may.
Yeah.
I guess I don't need a mic. Can you comment on open source thing? Is it kind of, can I go ahead and download your solution, or what do I need to contact you for that, or how does that work?
Yeah. In fact, concerning the data, first, the database is available online, so you can check it online. It depends of the data, but we have some contract with our partners that allow us or not allow us to share the data. So not all the database is available for downloading, but there is some images that are in the public domain. And concerning the system, actually is not open source. So if you want to use it, you just have to write me at this address, and we can see how we could use it on your data. But at the end, of course, we are doing some research. So open access and so on is our goal. And we will talk to that next week in Paris.
Perfect. Thanks, Sean. Are there any questions? If this is not the case, then let's have a short break for coffee for 15 minutes.
Merci. Already.
So, ladies and gentlemen, I have a pleasure to introduce our next speaker, Ara Ghazarian, Dr. Ghazarian, who is going to talk about machine learning approaches that help us to make our world more secure. So, Ara, floor is yours.
Thanks a lot. Thanks a lot for the introduction and also for the opportunity. Well, it's the conference about the culture, I understand, and I'm going to talk about security. And there you can ask yourself, where's the connection? But there is, and of course there is a connection to the security and safety in everywhere. The system that I'm going to talk about, I will present a commercially ready solution that we have developed. And I will present the capabilities of it. Those of you who are interested in security aspect of it, then there you go. And those of you who are here for the two very fancy letters nowadays, AI, you will see the capabilities of it at top level that we have developed. And luckily, the system, hopefully, is not very applicable to Armenian society. And I hope this statement will be there for forever, right? So, but unfortunately, in the worldwide, this is a very pending topic. And especially in the view of recent events, of the terror attacks, of the mass shootings, etc., there's a huge interest. And again, the system is developed, it's commercially ready, it's deployed, it works, and it protects. Now, I will present the system itself. If there's a time, I will show you some videos of how it works, like in action, and also what I'm planning to do if there are technical capabilities. I think most helpful personal stuff helped me out there. There will be a demo, so you can test it yourself, how the system works, what are the limits of it. So with all due respect, I will go on and present you the suite, the Stilla suite, what it does, what it is about. So, it's a security system based on computer vision. And yes, there is an AI component to it. And while many machine learning specialists, they know the limit of where the machine learning ends and possibly AI starts. And most of the commercial or sale people use this word with no deep understanding of what it actually is. But I will show you that I have the legit right to put these two letters here. And then the goal of this system is to work on top of CCTV cameras and aid security surveillance system, the personnel, the whole infrastructure. It is augmenting the security system. It helps to overcome the shortcomings of the system itself. And the limitations are obvious. You can bring more of them. I've just outlined 4 of them. Of course, limitation of human hardware resources. There are as many security guards as you can afford, or cameras out there that the security guards can be watching simultaneously. There are limitations of visual capabilities of security guards, like there's a monitor and just a person looking on the monitor can miss some important subject or action happening there. Of course, human factor errors. Those are very... It's a heavy job, and after 1 month, everyone will lose the attention, or I'm not talking about years of it, and these things happen. People fall asleep, they leave the room, etc. So this system is called to overcome these problems, and of course the cost. The more security guards, the more it will be the cost, and the cameras, etc. So the cost is of an importance issue, and I'll talk about the cost and in terms of in scope of the solution also later on. So how does it work? It's a security suite. So it is focused on the module. There are 3 main modules in it. It is focused on the module that is outlined on the left here. It's aggressive behavior and threatening object identification. So it is trained to identify aggressive behavior and threatening objects. Of course, there are some peculiar requests from customers, and we retrain, further train to understand more objects. But currently, firearms and cold weapon is of a key importance. Is the core? It's in the core, and it works the best. So firearms, all sorts of them. I will have hard times outlining how many types of weapon the system has seen and been trained on. And that is the AI part of the system. I will talk later. And well, it works very good. The way that the human eye would determine in a typical, I don't know, in a movie, if there's a gun, the system will see the gun. And if there's a firearm, a rifle, assault rifle, shotgun, or knife, the system will see it. So the core of the system is this module. But there are two more modules attached to it. It's a face identification and appearance identification. This is an important addition to the system. And the vehicle identification license plate tracking. The last one is not fancy already anymore in the world. There are many systems that do this. But in conjugation with the other two, this is an important module, and it works in a suite. So the way it happens is the following: if a person is handling a gun, threatening people or he's alone, but if he's possessing the gun and pointing it towards the crowds or towards anyone, anything, there are movements that the system recognizes, then the alert goes on. And what happens next is this: all the cameras are turned into search mode. All the cameras in the building and in the surrounding, they are looking for the person who looks like the attacker. And initially we started with the face recognition, but the problem there is that the face is not always visible. The person can be wearing a mask, he can be moving too fast, and if you have done face recognition, if you have approached this task, you have to know that face recognition works best when you look towards the camera, and there is a minimal angle of 30, 40 degrees or something. So if someone is like walking around with a head down, you will have hard times recognizing the person. And security guard does this because he knows also the appearance, the clothes, the height, the skin color, whatever. So we have upgraded this module. So now it looks in the appearance and looks for people who look like the attacker all over the building, and draws the map, indoor navigation map. This indoor navigation map is sent to the security guards, and security guards can follow the person, track him, and neutralize. I know it looks like science fiction movie thingy, but I will show you and demo how it works. And the same with the cars. So we can track with the license plate, we can track by the appearance. Of course, with the appearance, you will have a lot of false positives because there are as many black Mercedes in the street as one can get. But then in this case, sometimes it's based on the security personnel preferences, let's say, security system preferences. If they want too many false positives but not to miss the one, this particular one, there you go. And again, the problem is license plate. If you base on a license plate, you have to make sure it is visible, which is not always the case. So when the thing happens, system detects automatically, and then it alerts the security guard. There are alerts on the dashboards, there are alerts on mobile phones. If you have one attached to the system, you get instant notification with all the information, and I will show you how it works. This is a typical dashboard. One of the endpoint dashboards, not the administrator dashboard. So what it shows is the current view. On the top is it's a loss detection on the top left, and then the current view, and there is a pike which shows a pike of violence and object. There's two modules working in conjugation, giving the feed to the AI, which decides whether or not this is a attack or it's a false positive. And this AI part learns by the time on its own mistakes. So what happens then? So you got the frame, right? There is a weapon there in hand of this guy, and then this is the camera that is active and shows the detection of the threat. You can attach as many cameras to once. It works on the server. There's a limitation of hardware. We worked a lot to minimize these resources or limitations. a typical server, but still, this typical server will run something like 60 cameras. And it's based on the GPU. I will answer possible questions on that later on. And then these 60 cameras that are attached to the system, the one that detects the weapon becomes active. It gets on the top of the dashboard and flashes the red, and you get this frame. The same frame is being distributed to all the security guards who are attached to the system. And, well, you can ask how good does it work, how good it is in detecting first, and of course in non-detected, like in not doing false alarms. That was one of the big problems when we were developing the system. Just for your information, we are talking about video feeds. So if you lower the frames of the video feed to realistic 5 frames per second, right? In the typical day, each camera will output something in a work hour. I will limit to 10 hours of working hour, omitting the night. 10 hours will give you 220,000 frames. If you're looking for a weapon in each frame, and you have to because you don't want to miss it, then your specificity have to be 99,99976. This number frightens computer vision specialists because not to do mistakes with this number of nines is a big feat, all right? So the way we have solved it, I will talk about it shortly. It's a patented technology. The algorithm is patented. But yes, we have utilized that we are not looking in the one frame, but in the video feed. So we take into account that one too. And also, we were inspired by the way human eye, or actually eagle eye, works and the vision of eagle eye. I will get to that. But I will show you some numbers, right? So I have scientific background, physics, optics, and then dived into IT, data science, and computer vision. So I'm a science guy, and sales are good, great, IT companies, etc. But always I'm this guy in the company that says, okay, the numbers. I have to have numbers that are scientific grade. So what I've done is I've tested the system with several types of weapons, with different lighting conditions. Of course it matters. The better it is visible, the better the system will distinguish the gun from a mobile phone, etc. And just like taking the distance into account too. And there are some numbers, 4, 8, 12, and yes, 35 meters. This might surprise if you look on the imagery. This might surprise you. 35 meters is quite a lot to spot anything, I'm not even talking about distinguishing gun from a mobile phone. And mind you, this thing in my hand from 35 meters, if I hold it like this, will definitely look like a gun, right? And if you just train a system telling this from that, it will do a lot of mistakes. With a typical scenario, this is one of the cases that we have shot this video from a drone. And yes, there are some 35 meters. And this is a video feed from 4K camera. The resolution of it is 4,000 something by 2,000 something, the numbers. And the way the way the system analyzes it, it zooms in a particular region and makes sure that whatever it looks on is a weapon. Another example from the top, yes, it looks like, yeah, there is a rifle in the hand, zooms in, the alert goes off. The system is trained to distinguish IR, night vision, detections also. Yeah, there you go. If you can tell that it's a weapon, the system most likely will do, and most likely it will do much better. Because again, I'm not saying that it is smarter or it has the subconscious that we do have, but the thing is, it zooms in. And you have to do this same thing to be able to work on par. You have to be able to zoom in each frame fast like that. The computer can do that. Humans, no, I'm not sure. Sometimes, yes, the security guards will zoom in to make sure what is there. Is it an umbrella? Is it a weapon? But it's sometimes, not in each and every frame. So some more examples, and here are the numbers. The way these numbers are derived is the following. So we took into account the time that is needed for the gun to be detected. Of course, if I'm talking about detection from 12 meters, I can walk the whole day and there will be one detection. But this has to be fast, and seconds do matter. And these are the numbers of detections and versus the distances for the gun, assault rifle, shotgun, and knife. This is a light environment, well-lit, nice environment. It drops down a bit in the dark environment. Knife is a bit hard to distinguish, I must confess, because there are too many false positives. We have to increase the threshold, so knives are a bit, when the threshold to be sure that it's a knife is a bit higher, so the detections are lower. And for the IR, of course, we cannot go too far. The way IR camera works, it illuminates with IR and receives the object, so it cannot go too far. So 4 and 8 meters here we are. About the false positives. Again, I will repeat, this is one of the main problems we have faced. In the environment typical, this is one of our IT office rooms, and there are too many people there, 20 or so, 30 people, walking around with mobile phones, handling those black mice on the tables and stuff like that. So all of this can, in some angles and time of the day, during like 10 hours, 12, they can trigger the alarm. So initially we had false positives of number, let's say 40 a day, which is too much. If you talk to security guard, they say, oh yeah, it's no problem, it's better to have it than to miss the actual thing. Yeah, they say this first day, second, third, but then they get annoyed. So 30, 40 false positives a day is no-go. So this is a typical experiment. We put this in 8 cameras, the 7, well, the 8 is not visible, it's on the back. But 8 cameras, 3-4 days, overall count 287 office hours, so active hours. And they were just 5 false positives. If you calculate the specificity, this is the number. So again, some 9s we are kind of proud of. And I will just show you what false positive looks like. They are from typical, I had this minicam which I'm using for demos. It's a small IP camera. I stick to the wall whenever I don't have the ability to take the bigger real IP camera. And it's kind of low quality, right? The sensor is 1 millimeter on 1 millimeter. So this camera does the whole false positive things. The other cameras are behaving properly. So the typical, somehow it's a rifle there. There is a gun there. Again, from far a gun. There are 5 of this type of images in 287 hours. So if you think about it, if you divide by 10 hours a day, etc., it's 1 month. So in 1 month, 5 false, it is affordable, right? So, and then there is this actually looks like a gun. I had to zoom in and change the contrast to make sure that the guy is not taking one of my toys that I have in the office around to test the system. So the way it works, again, I would say, it kind of resembles the vision, the way the human person would look. You have this overview, and then you have a suspicion. There might be something, and then you focus on this area and zoom in or sharpen your sight on this area. It's the same that this AI works. There are 2 modules. One of them looks on the overview. And again, I would love to have the original resolution image being analyzed, but you would need a huge server to analyze 4K resolution frames in 5 frames per second. So everyone who does object recognition or computer vision on video feed, they lower the resolution. And the minimum resolution can be, well, it can be really small, like 112 to 112. That is the resolution people use for action detection. And you can imagine 112 on 112 pixel, it's something that hardly you can tell, like dancing from violence act. That's why we had to compromise and we had to develop our own system. There are 2 sight modes. One of them looks on the overview. Whenever there is a suspicion, the second one kicks in, zooms in, and makes sure that the first one did the thing right. So that's why the first one we call Scylla, the second one is Charybda, some code names. That's how it works. Zooms in the original resolution, 4K, perfect. And that's why this type of an image, where you can hardly see anything, becomes something like this, then zooming, then yes, this is a gun. So this is how it works from 35 meters away. And next thing what happens is the alert. Response is sent to the units, and the information, now it's a bit upgraded 2 days already, but nevertheless. It contains all information. It contains much more than typically one gets when there is a misfortunate terror attack or something like that. And it contains the frame of the happening. So it has information, what person looks like, the potential attacker, what he is possessing, where it is, and also there is a navigation information, so it's something like, it's clickable, so like second floor, above the hallway, etc. So the whole information for the security guards helps to track that thing and to neutralize it. Also, we have included here so-called smart suspect identification system. You can attach the database of faces or people to this system. Then you press this button, and then it does the matching and comes back with the matches that your potential suspect databases have. And the face, again, I would outline here. So these are the accuracy metrics of our face detection algorithm. And I have put two tables exactly for the reason for near and far, of course, because the face size does matter in the recognition. And if you look on the resolution, face size on the frame, etc., there are limits, right? So we can say 97, but 97 should be with a face which is 112 pixels wide. So it's for a close-up. If a person passes through under camera, then yes, we can recognize the person. But if it's from far, then there you go. You have to know the limits. That's why now we have changed. Face is fine. If you want face, you will have it. But the appearance is much more important, we think. And this is a typical scenario how it can be used also for peaceful use cases. So it's kind of one of the famous pizza providing sellers and like these companies. They took this module only. They bought this module only. We called it asset tracking because the asset can be anything. It can be face of a human. It can be the whole person. It can be a bag. It can be even a pizza. The way it works is the following. It looks for the object, finds it, and then tracks it by the resemblance. So a person can be turning and hiding the face, etc. It still will be in the focus. And it's just and then this person is distributed to all the cameras, and all the cameras track this person and report. We have seen this guy here, this guy here, this guy here. So he went to food court, then he went to the playground, and then he went to this shop and that shop and that shop. For some reason, this is an important information. I have no idea. I'm just doing the text part. So tracking is there. And the last module is the so-called vehicle identification and tracking module. It works both on the appearance of the car and also on the license plate. So this is just one of the streets in Khanjan in Yerevan, so the number is Armenian. But we have the system running in Minsk and in Egypt. Yeah, this is the camera from Minsk. Minsk, they don't want the numbers. They have low-res camera, so it cannot read the numbers. They just want the type of car and the lanes. So they want this for traffic regulation. And the way it works, again, some more numbers we're proud of. We have brought the system to sophisticated upper limits. And yeah, these are the numbers that, again, there are videos and demos that you can see, request, etc. And a small upgrade of the system. As long as you can see the object, which is car, then you can distribute it or understand parking lot solution. There you go. Some minor changes here and there, and then you can distinguish which parking lot is free, which is occupied, and guide people to this free spots. This is also working. This one is in Austria. So, what opportunities Stila provides? Again, live stream capability of it, like live, real-time working of it, allows instant detections. It takes 2 to 4 seconds, depends on the connection speed, etc., but then you get it instantly. And it is capable of recognizing different actions, and not only actions, but also the object. And in 2 words, I would say, both matters, but they compromise each other, and if the weapon is very obvious, then it doesn't matter, the action doesn't matter. If there's a gun in the hand, then the action, even if a person is standing still, you will have the alert. And vice versa. If someone is running with a gun, the gun is blurry, smudged, or whatever, but then he's pointing on people or doing the violence movements, you will have the trigger, the alert triggered again. And face biometrics, this all the modules, they are supplementary. They help the system to work in a suite. They help us to provide the overall security, and they complement each other in cases where a person, for example, with a weapon, he drops the weapon, but then he has to be still tracked because he's an attacker or aggressive person. And you cannot rely on the weapon only. You have to track the person. That's why the other modules are kicked in and help security guys to neutralize. And as I said, it can be deployed on drones to support larger area supervision, like huge crowds, etc. It is possible. And again, some statements. I think I have went through all of them. And one thing that I didn't mention, the AI part, which I bragged about in the beginning. So there is a moment you teach the system, computer vision system. You teach it. It performs good, but it has to be supervised learning. You have to check the outcome. You have to check the data set that you provide. It was cherry picked in the beginning, starting from some huge amount actually. That's one of the key points that we have. Smart algorithm, and also the data set. We have put a lot of efforts on the data set. Starting from one point, the system turned to be smart enough to find the weapons on its own and do minimal mistakes. The percentage of the mistakes is as low that it's not worth checking the created data set from the system. So it crawls in the internet. God bless Instagram with all the hashtags. You give the hashtag gun, there are several hundreds of millions of images which might have gone there. So these images and videos are being processed by the system. The system gets this information, puts in a data set, retrains it. Yes, you might say, well, it learns on something that it already knows. But yes, it does matter. It does allow slow generalization. You taught a system, black gun, silver gun, wooden handle gun, etc., etc. But there is an upgrade. There's a longer gun. There's a smaller gun, etc. The system starts to distinguish these deviations, and the deviations spread. And this is why we call it AI. The system teaches itself now, right now, as I speak. The system is gaining the new data set for the next iteration of learning. And it proves it works better and better and better. Not only the action and object detection model, but also the decision maker that takes this information and shoots out the alert. So this is the team that currently, well, it is growing, but this is the core of the team. And I will mention our CEO, which started the thing back in Mexico. Then I jumped into the team, and we brought it to the commercial level. And, well, we are already featured in a number of media, and the sponsors is our mother company, the Develando. We call it a startup, though it is kind of already established and it has a name on its own, but it was subsidized. It was sponsored by Develando. And Startup Bootcamp, we were chosen to be among 9 startups to be accelerated in Amsterdam. And the Atomico Group, which is a big Mexican guy who also sponsored us. So with this, thank you for your attention. There are some video demonstrations, and also I will try to set up a demo and then you can come and test the system yourself. And I'm open for your questions.
Thank you, Aaron. Thank you for your informative talk. I believe I personally have a lot of questions, but we're moving to auditorium. So, are there any questions from you? That's you. Please.
About the interesting presentation.
Thanks.
Very impressive results. But can you say about methodology, for example, GAN detection, and just security related, for example, GAN? Because GAN, keeping in hand, is a complex picture. You have to be able to detect the person, just be invariant, and so. Can you say a few words about methodology? Thank you.
Sure. Well, I would not be able to disclose the whole details. Of course, it's kind of commercial product, etc. But yes, of course, this matters. A gun on a table, a gun on a wall will never trigger the system. Of course, it was trained on the guns in the hand, and
Because just machine learning here, just by neural nets, it's not so effective.
well, again, that part is the neural network is our own proprietary one. If you want to get the models which are the ideas, it's kind of a mixture. I don't know if you're aware of these models, but it's kind of a mixture of YOLO and faster RCNN. It takes the good from both. YOLO is very good, it's very fast, but it lacks a bit of accuracy. Faster RCNN is much more accurate, but then it cannot work in parallel, and it's slower, etc., etc. We took the ideas of networking from both, and yeah, well, it takes this. It is based on the features of typically the gun that you would see and say this is a gun. The same way it looks on the features, and it's kind of a bit hard to say what exactly triggers it over the threshold. But definitely one thing for sure, the gun should be in the hand. That's the way it was trained. It has never seen a gun not in the hand. And also the action, of course. The action also matters. Training, this thing.
There was another question.
So, briefly speaking, as I understand it correctly, the system is based on first item recognition, and then you have to monitor the situation. But if you go back to the real security situation, so what are doing first, no killer will demonstrate his gun or his shotgun, usually it's a kind of, maybe amateur, something like this. What would like to say? Like the real situation is what do the real security staff? They are monitoring the situation and they are monitoring the behavioral, it's a kind of behavioral monitoring. So, did you try something like this? And any thought? So, what can we do? Thank you.
Thanks a lot for the question. Yes, we are being asked this type of questions, but we are being asked much more unrealistic, let's say. What if a gun is in a backpack? So we do work there. Now we have this developed. Of course, there is an R&D, of course. The R&D goes in several directions. Thermal cameras. We are developing the system to be working with thermal cameras. Of course, they are expensive, the resolution is low, etc., but still, we are now in discussion with a school, and they are ready to put this and test it. Thermal cameras under the cloth, it shows. And we have a model that will distinguish and raise alert if it sees the item that looks like. All right? So one thing is this, this guy's thing. But in terms of behavior, yes, we are trying to do that too, but it's very hard to distinguish which is a suspicious behavior from that of anxiousness, etc., especially in the areas where we are targeting mostly, schools, for example. I mean, if you look on the typical school like how like rest, right? And when they have a rest, and when they jump and run and jump on each other, etc. It's very hard to distinguish this behavior from violence or potentially violence behavior. So there is a model of action, of course, and if you base only on object recognition, this thing wouldn't work, and you wouldn't have the accuracy of this level. There will be too many false positives, and I would have to shut it down from day one. But the action matters. But it depends on, there is a trade-off. And so this feed goes into the model, which is we call decision maker, and decision is made on both the action and the object. Sometimes object numbers prevail, sometimes the action prevails. But what you say, for example, no one is taking out. So some cases, of course, let's say, well, we are monitoring all these terror attacks, etc. In some cases, for example, they request in the hotel in Bay Area, let me remember. I don't remember which one, our sales guy right now. They want, they are in development right now, this model. They want big bags to be tracked. Because, well, the last unfortunate event in America from the hotel roof, etc. The guy was taking in 5 times, he took big guns inside the room. So they want big guns in big bugs, like big suitcases. So they want to track this type of behavior. It is possible. Asset tracking can do that, but you have to kind of define what do you mean by suspicious behavior. And of course, the system wouldn't track all of this suspicious behavior because there must be some kind of a abstract thinking there, etc., background, and this is based only on vision. So we're not claiming this will replace human, but it will aid, especially in the cases where the aid can be obvious. Like, yes, in cases when a handgun is already withdrawn and a person is trying to attack, then you know and you can alert the system. And the relay system that we have developed, and it's being, I don't know if I can disclose this, but it's in one of the schools in Clark County. They have attached this system to the relay alert system, which closes the doors and raises the alerts. The first time you see the gun, it does the whole thing. Maybe it hopefully, someday, if it saves one single life by shutting one particular door, there you go. The system is already covered the whole efforts and money spent on it.
So your system cannot predict a dangerous situation?
No, not right now. We are working on that as a next step. But right now, the attacker should be there, and it should be an active shooter, or the attack should be obvious. So predicting, not for the moment.
Okay, thank you.
So I want to touch upon an ethical question. Usually when it is a pitch like this, it's usually oriented on the client. So what if we look at the picture from the perspective of false positive? A person is taken down and it's false positive. I mean, it's a stress, it's a moral damage and whatever it is. Good case scenario, it's just stress. Bad case scenario, it's heart attack and person dies because of the false alarm. What are the responsibilities of the company and how you consider them?
Yeah, sure. Well, thanks for the question, but this is an alerting system, right? You are being sent the frame, and it's upon a human to decide whether or not these are really happening actions, and there is a video feed that is showing whether or not it's an actual attack or a gun or a hair dryer in the hand of a person. So the system doesn't take any actions, luckily, and we'll hope in the near future that will not be the case, except these alarm thingies and closing the doors, it's shutting the doors, etc. But no harmful effect will be, the actions will be taken by the system. And it's just merely alerting security personnel, drawing their attention, raising their awareness to follow the actions.
Just elaborate, because there was the beginning of the slide, the factor of human error, which in this case
more or less solves that. But in case you are just delegating responsibility to human again, which is basically leaving again to human error.
Not always the case. Human error can be a person as guard sleeping on a table or getting out to restroom or something. That type of human error. Anyway, this will be visible on the screen. The action itself, what is happening, and the human will be the guy who will take responsibility of whether or not there are actions to take or not. And normally security guards do not take. They call the police, etc. They go in the site and take actions there. There are not turrets with guns and to press the button for the moment, at least. And then that is the person will go there in person, see and neutralize. But what he will have information. He will have much more information than typically someone from underneath the table will call and say, oh, there's a gun, a person shooting a gun. Who is he? What he looks like? I have no idea. I just heard shots. And there you have the whole picture there, the person, what he hands, what is in his hand, etc. And maybe even the person name or etc.
Unfortunately, I have to cut it here because we are running short a little bit. So can I ask speakers to approach? We're going to have a panel discussion. So Arab, please take a seat if possible. Shahan, please join us. And I think Professor Polosyan wanted to join, but Haraj, maybe you will substitute and represent Armenia, because we are going to talk about the collaboration potentials. So if there is anybody wanting to represent Armenia, so the floor is yours. And may I ask to raise up the slides? Thank you. So the idea here for today's discussion is to basically see if there is certain potential, be it academic, be it industrial, of a collaboration with folks around and with the data center. Oh, Professor Polosyan, you are kindly requested to the stage for the panel discussion. Please. Yes, we're going to have a small panel discussion in the conclusion to outline the possibilities for the further collaboration. So may I ask to put the last slide, please? Yes, there it is. Thank you. So the main idea is, as mentioned before, to see if there is any potential. And first of all, for understanding that, I would like to actually see if you have already done such kind of a cross-organizational collaboration or something. So Ara, please, maybe we'll start from you.
Oh, yeah. Well, as I mentioned, this thing wouldn't sit on. This thing wouldn't be developed if not collaboration. And by collaboration, I mean, first of all, the sponsors, and also not only like financial sponsors, but also the ones that raise the awareness, etc. For example, Startup Bootcamp. They accelerated us and they brought us to some platforms where we can raise the awareness and show our product and be distributed further on. And collaboration currently as a main point of collaboration, I would still mention the mother company, Develando, which is an AI accelerator, AI solution provider. With Astilla, I'm the CTO of it, didn't present myself. I'm more specialized in this particular niche of computer vision versus security. But we have many more solutions, in fintech, surtech, etc. And we do provide not only, for the moment, we do have this kind of services to provide, to develop the solution and provide to a potential client, but also we have our own products. So it's both are there, and for the moment I would say we are collaborating mostly with US and some of EU companies. There can be, the list is over there on the websites, and if you want to get to these companies through us, or if any of potential possible future clients want to have some kind of a solution out there, we are more than open to discuss this.
Since you mentioned the patent issue, so thank you first of all. Since you mentioned the patent issue, so how does that work in the domain of research and development with the academic sector?
Well, that's kind of, well, I had to quit the academics to dive into this thing. And in that respect, of course, I was most of my life, let's say, like the productive, educational, etc. I was in academia in different countries and universities.
I guess I rephrased it not that properly. So is there a potential for SILA to be as a collaborator with academia? Do you see that happening? Or since all portfolio is basically kind of commercial and you don't want to open certain things to the public and you don't really see as of now collaboration points. So that would be the question.
We do have products, we do have projects, we do have collaborators with universities, with medical institutions. We are developing a product on, not going into detail, but on the skin conditions, etc. And from their point, it's that the agreement is the following. All right, we do work on commercial. For some way they solve this legally. It's on their part. It's their product. But they can also publish this. They can also publish the results and make it available to the whole world.
Okay, thank you. So Ara will be around, so if there are any academic representatives, feel free to talk to him. I guess you are around, right?
Yeah, sure.
Shane, what about you?
Yes, actually we have a lot of collaborations that are running. For the heritage part, actually, we have two main projects with two libraries, two institutions. It's a congregate of different libraries who want to digitize their collections and to do something with the digitizations. It's especially the Nubar library of HGBU in Paris and the Bulac library in Paris too. They want to digitize thousands and thousands archives, not only in Armenian, but especially in Armenian. And the main difficulty was, in fact, libraries don't know how to manage such a project. Digitization is something new, or extraction of information new too, and how to okay, you have some text, authorized text, but what can I do with that? It's something unclear for people how we can valorize it and interest people. So we are working on it with them. And so the main challenge is to develop some interface in order to interest people who want to discover this heritage. And with academics, we are starting a collaboration actually with the University of Louvain in Belgium for natural language processing. Actually, we are developing some corpus and some lexical databases in order to bring for people, for everybody, databases for training systems. And the main problem of that was, in fact, the interoperability of the data. We are using different kind of input and output, and it was very, very difficult to agree for go on in the project.
Okay, thank you. Professor Poulsen, I assume Academy has a big experience, so maybe you can also comment on what can be done better and what were the lessons learned.
I am from Academy of Sciences Institutes for Problems of Informatics and Automation, and our director yesterday, Racha Satrian, introduced to some aspects of our doing. So I will focus on one which immediately, directly relate to my activity. I am working in my direction is a cognitive algorithm models, and that was established by our, founder of our institute, Sergei Mergelyan, in 1973, and it was continuing the line of one of the creators of computers, Andrei Markov School. So we are working on fundamental problems and trying to find application to different areas. In this, just to say a few words what we did, actually we pretend to give a model of cognitive activity and take as a first these advances as an innovation or finding of algorithms. Algorithms is a first attempt, and that is the most interesting, that one mental activity was passed to computer. So we continue this line, and in this, in parallel, what we find as a model in conceptually, we apply on examine on applications. And we consider just, say, examination field, some combinatorial games. Why combinatorial games? Because it is a very good model, human universe, and just unsolved problem, and combinatorial games as one good example for solving that. So we have a lot of advances about each of them. We have to have special talk. And we collaborate in what relates collaboration. So I would emphasize two aspects. First aspect relates to conceptual lines. We are one of unique laboratories and unique direction in our institute which can compose different theoretical backgrounds. We have just lines of bright scientists work in our institute who worked in algorithmic theory, complexity theory, logical, combinatorics, and so our applications are they combining. And sometimes it is difficult to find a response from particular laboratories who are concentrating T1. For example, our search, and thanks to internet, now we have opportunity to look different universities and we find, but that's a difficult process. That's one thing. Second, I would say about applications. So we have a good experience with Montreal University. In frame of NATO project, we did this application of our system, decision-making system for problem of defending own ships from rocket attacks. And that was really recognized, published in very well publications. And second application...
it was not a military secret?
Yeah, not military. It was with Montreal University, although just it was open project. And second, it was a good, again, project, lecture notes in computer science, that is a defense of networks from hacker attacks. And here, again, we have a really good results. It was even just in some way used by Kaspersky's laboratory and So what I would think...
So if I put it in a short way, so I understand you have a big portfolio of collaboration. So is there a specific list of topics, tell me, let me phrase it like this, that you are currently looking for collaborators specifically?
Yeah, we have...
So in short, if you can comment on that.
Yeah, we are on this stage because just we have intermediate position when we have conceptual, say, framework, which we believe and try to bring to audience with publishing. But the problem is just a common model of our just cognizing. We're focusing this part cognizing. And we are looking for, in European universities, in American universities, very deeply, to find, first of all, researchers who could understand conceptually. That is the most difficult part. And in parallel, we apply or we communicate with companies, particularly we have one project again related to defense, to just explain companies, these offices, that they see the advantages that they can apply. Yeah, that is not easy process. Maybe some site or some place where we can put these our advantages or short description about that will be helpful. So that's my opinion.
Thank you, Professor Polosan. So Shahin, are there any specific topics as of now that you are looking for collaborators for?
Difficult to answer. Actually, we are working on post-processing of the results of the OCR system. And yes, we are looking for some partners for doing that. I don't think that Calfa will do everything for the post-processing task. Actually, we are discussing with the University of Louvain, who has some collaborators in Yerevan. in order to develop a system in common with the data set we will provide them.
So is it only post-processing, or there is something else? Or it's mainly post-processing?
No, it's
Okay.
Can you please?
Is it mainly, so you mentioned post-processing as a topic. Is it the only one, or there is also another topic?
No, there is other topics.
For instance?
Can you answer during this time? I will think of that.
We can move to,
don't have any
okay,
idea
okay, take your
actually.
time, and Ara, maybe you can jump in and tell if there are specific topics that Sila is looking for collaborators,
Well,
be it in a vision field or
yeah, sure. In me as I'm leading this research and development part of it, and especially the data science part of it. Of course, I have some pending ideas that have shown some promises. The only problem there is that what I have to probably discuss with potential collaborator, and also with our part, with the lower part, right? Like the rules in commercial versus scientific collaboration. I have to make sure that there are no hiccups, and we are on a clear ground on the, copyright, I would say. But the ideas are, we do have some ideas which, again, as I said, have shown very promising results. And also, speaking of, there are ideas for future, right? This predictive parts, the anomaly detection, some algorithms on optical flow, hashing, etc., etc. We do have them, but we don't have the scientific resource, especially focused on these type of topics. So if there are some very computer vision advanced, and especially in terms of if they have some experience with motion analysis, etc., we'll be more than happy to discuss. And then it will bring to, we have to just define the grounds, the limits, commercial versus scientific. There can be collaboration for sure, we have to define that.
Okay, since we are running out of time here and I don't want to delay you from lovely lunch, so I'm gonna cut it here. And presenters are here, so feel free to come by and approach them and speak on potential collaborations. I think this was a good start, so thank you again for coming and joining this panel. So let's thank speakers again, and with this, I wish you a lovely lunch.